So we're going to try and look at solving trigonometric equations and how this actually works. So we've worked with graphing sines and cosines using the unit circle to figure out the values of sines and cosines. So now we're going to learn how to solve trig equations. Normally, what we say is we have an angle. And what we do with the angle, which is our x's that you can kind of see down here, we take those angles and then we input them into a trig function. So sine, cosine, tangent, cotangent, whatever. And that gives us, a value of sine or cosine or tangent. That's what it is. So we take an input, we put it into a function, and we get out, a value. So what we're going to be working on is how do we go backwards? How do we take a value, put it into something, and get an angle out? How do we reverse this pattern? Because what if we want to find the angle where something happens? So that's where we're going about this. So we kind of have to fundamentally think about these graphs a little bit differently, because instead of looking for a value of sine, we're looking for an angle. So this is what the graph looks like. So if we were to say, trying to figure out when the sine, let's say, was 0.5, we could graph sine, so we see this. Then we could graph 0.5, and we could find all of these intersecting points. That's very rudimentary. We don't want to have to do that. We want to have something a little simpler. So that's what I'm going to show you guys how to do. So normally, when we graph sine, we see something. It starts at 0, and it kind of goes up and down and up and down and so on. Well, that's regular sine. Now, the function that allows us to take a value and get out an angle, that is called the arcsine. And so you'll see it's basically called the inverse. Now, the way that the arcsine works is that you're going to have the values are going to create the x-axis instead of angles, and the vertical axis will then be your angles. So what happens here, so imagine this is like 1 and this is -1. What happens is sine starts at 0 and it kind of does this thing. So what we actually see is this graph is going to kind of double up on itself. Now what I mean by that is one of the rules for a function, a function has to have only one output per input. So what that means is, if I lock down any x value, so think about these, I can only have one value of y. Well, you see here how I have 2. That's not allowed. So what happens with this type of graph is, instead of drawing it like this, now you can imagine this going on forever, right? We can't do that with Arcsine because of this idea that you're going to have multiple places, multiple values that it could be. So what they do is, instead of graphing the whole thing, they're going to graph just part of it. And so what happens is you get something that looks similar to that. Okay, so kind of look at this graph and think about turning it. So what this is going to tell us is that for our value, now let's say this is going to be like -pi/2, and this is going to be pi/2. So we only have a short range of values that we can have, and you can see over here on the right that it's -90 to 90. So you don't have to know about really the graphing of arcsine. Just understand that it's got a limited range that you can answer, because obviously sines and cosines repeat. We can't do that with a function. The function has to be the same number all the time. So we have a very tight window on how this is going to work. So this is just kind of in reverse of how all this stuff works. So that's what kind of arcsine does. Arccosine works very similarly, right? We're taking a value of cosine, we put it into arcsine, or excuse me, arccosine, and we get an angle. So arccosine, again, it still can go from -1 to 1, okay? But what it's going to look like is, because it starts at 1, okay? It starts its graph at 1, and it is going to cycle through very quickly. So it starts at 1 at angle 0, and it is going to go all the way up. So as opposed to the last graph that started at -90, right? This graph starts at 0 and goes all the way up to pi, or 180 degrees. Okay, so this is what's kind of weird. It's because once you go around that, so like imagine if I went below into a negative value, see how I start repeating? And if I kept going, I would repeat again. So what we're going to have here is a different range of values that can happen. Your values of arccosine will always give you answers between 0 and pi, or 0 and 180. It can't be anything outside of that. And then lastly, tangent. So tangent's a little weird in the sense that it has an infinite range normally. So we can put in any number into tangent. So, you know, if we take a value of tangent and we plug it into arctangent, we get an angle. Okay. Now, here's the thing. With the other answers, we could only put in, you know, our input into Arcsine could only be between -1 and 1. And for Arcsine, same thing. We can only go from -1 to 1. And our output was a little different. So this output we could only get from 0 to pi. For this one up here, our output was going to be from -pi/2 to pi/2. Now for arctan, we're going to have our input can be all real numbers. We can put in any number we want because tangent has an unlimited range. So let me see if I can show you what the graph looks like here. So the way that tangent's going to be, we can input anything we want. So this goes all the way to -infinity and infinity. But just like how sine was, we're only going to get answers from, this is going to be from -pi/2 to pi/2. We can't get any more than that because after that, tangent's going to start, you know, you're going to have an asymptote and it's going to start repeating itself. So its output is going to be from -pi/2, and it can't be pi/2, sorry, to pi/2. So these are functions that are going to give us angles out. Now this is a list that you may want to write down. Basically, it says that what I'm looking for is an angle. And so I place a value of sine, cosine, or tangent into these inverse functions, and it's going to give me what angle it is, these x values. And the angles will be in these windows for us. So we're not going to necessarily get the answer we're looking for, and we'll look at that in a minute, but we use the logic of what we know about the unit circle to figure out all the places we can get answers. But just realize these functions are, in this mode of thinking, will help us solve trigonometric equations.